Okay, question 8 is the coordinate geometry question, and they've been incredibly kind because they've drawn the diagram for you. As soon as you spot the coordinate geometry question, be prepared to draw your own diagram usually. So they tell you in words what the diagram's of, so they give you the coordinates of A, B and C, which is P, Q. Remember, when they give you stuff like this, they're giving you an X and a Y. Okay. And we've got point D. They've actually worked out the midpoint for you, but we don't know what PQ is. So that's the first thing we've got to find. We've got to find out the coordinates of this point here. Yeah. So this, they've drawn it for you. Otherwise, people will make the mistake of finding the midpoint of these two given points, which is not what you want. So you have to use the midpoint recipe, if you like, knowing that you've got the answer. Okay. So for the midpoint, you average the x's. Okay, and you average the y's. So the x's we have to average, the answer is going to be 8, and that must be the average of 1 and p. So that's one way to do it using your midpoint recipe. Okay. There are other ways to do it. You could actually think that the gap from A to D, okay, as we go across, is going to be the same gap as from D to C, because D is exactly halfway. So there are ways of doing it just using the diagram, which are great if you want to use them. Then we've got the line L, which passes through D and is perpendicular to AC, and we need an equation for L. Okay. I don't think we need to think about it intersecting at E yet. We've got what we need for an equation, because for an equation of a line we need two things. This has happened already on this paper. Okay. But for a line we need a point and a gradient, so we can use the y minus y1 recipe. Okay. What's the point? Well, it tells me it passes through D, and I've got the coordinates of D. Hooray. Okay, and then it's perpendicular to AC, so that now we've got a bit of work to do. So we've got this word perpendicular to deal with, but firstly we've got AC. Now, A is a point I know, and C is a point I know if I've done part A. So if I have two known points, I can work out the gradient of AC using the two-point method for gradients, which is going to be a subtraction divided by another subtraction. Okay. But I want to be perpendicular to AC, so I need to work out the perpendicular gradient. Okay? Set up a point, set up a gradient, and then you can use the y minus y1 recipe, but don't forget to get your answer into this form. And then finally, we want the x coordinate at E. Exact, so that means leave it as a fraction, don't give it as a decimal, whatever you do. Okay? So find the exact x coordinate of E. What was E? E was this bit. Something intersects AB at E. Intersect is a trigger word. So AB is the line like that. Okay, now we haven't got the equation of AB yet, but because this matches this, okay, the line AB has got a very simple equation. Okay, well, it's a horizontal line, so its equation is y equals some value. Okay, so intersection, trigger word meaning solve simultaneous equations, but one of those simultaneous equations is just y equals a number. Okay. The other one is, what is it that's intersecting with AB? Well, it's this line that I've got the equation of in part B. So if I take my equation from part B and solve simultaneously with y equals the number, the equation of this line here, in other words, I'm plugging this value for y into the equation you've got in B, and that will give you something you can solve to find the x coordinate of E.